The pituitary gland. The next gland to be falsely incriminated was the anterior lobe of the pituitary. This most important gland lies well protected in a bony capsule at the base of the skull. It has a vast number of functions in the body, among which is the regulation of all the other important endocrine glands. The fact that various signs of anterior pituitary deficiency are often associated with obesity raised the hope that the seat of the disorder might be in this gland. But although a large number of pituitary hormones have been isolated and many extracts of the gland prepared, not a single one or any combination of such factors proved to be of any value in the treatment of obesity. Quite recently, however, a fat-mobilizing factor has been found in pituitary glands, but it is still too early to say whether this factor is destined to play a role in the treatment of obesity. The adrenals. Recently, a long series of brilliant discoveries concerning the working of the adrenal or suprarenal glands, small bodies which sit atop the kidneys, have created tremendous interest. This interest also turned to the problem of obesity when it was discovered that a condition which in some respects resembles a severe case of obesity, the so-called Cushing's syndrome, was caused by a glandular new growth of the adrenals or by their excessive stimulation with ACTH, which is the pituitary hormone governing the activity of the outer rind or cortex of the adrenals. When we learned that an abnormal stimulation of the adrenal cortex could produce signs that resemble true obesity, this knowledge furnished no practical means of treating obesity by decreasing the activity of the adrenal cortex. There is no evidence to suggest that in obesity there is any excess of adrenocortical activity. In fact, all the evidence points to the contrary. There seems to be rather a lack of adrenocortical function and a decrease in the secretion of ACTH from the anterior pituitary lobe. So here again our search for the mechanism which produces obesity led us into a blind alley. Recently, many students of obesity have reverted to the nihilistic attitude that obesity is caused simply by overeating and that it can only be cured by undereating. The diencephalon or hypothalamus. For those of us who refused to be discouraged, there remained one slight hope. Buried deep down in the massive human brain there is a part which we have in common with all vertebrate animals, the so-called diencephalon. It is a very primitive part of the brain and has in man been almost smothered by the huge masses of nervous tissue with which we think, reason and voluntarily move our body. The diencephalon is the part from which the central nervous system controls all the automatic animal functions of the body, such as breathing, the heartbeat, digestion, sleep, sex, the urinary system, the autonomous or vegetative nervous system, and via the pituitary the whole interplay of the endocrine glands. It was therefore not unreasonable to suppose that the complex operation of storing and issuing fuel to the body might also be controlled by the diencephalon. It has long been known that the content of sugar, another form of fuel, in the blood depends on a certain nervous center in the diencephalon. When this center is destroyed in laboratory animals, they develop a condition rather similar to human stable diabetes. It has also long been known that the destruction of another diencephalic center produces a voracious appetite and a rapid gain in weight in animals which never get fat spontaneously. The fat bank. Assuming that in man such a center controlling the movement of fat does exist, its function would have to be much like that of a bank. When the body assimilates from the intestinal tract more fuel than it needs at the moment, this surplus is deposited in what may be compared with a current account. Out of this account it can always be withdrawn as required. All normal fat reserves are in such a current account, and it is probable that a diencephalic center manages the deposits and withdrawals. When now, for reasons which will be discussed later, the deposits grow rapidly while small withdrawals become more frequent, a point may be reached which goes beyond the diencephalon's banking capacity. Just as a banker might suggest to a wealthy client that instead of accumulating a large and unmanageable current account he should invest his surplus capital, the body appears to establish a fixed deposit into which all surplus funds go but from which they can no longer be withdrawn by the procedure used in a current account. In this way the diencephalic fat bank frees itself from all work which goes beyond its normal banking capacity. The onset of obesity dates from the moment the diencephalon adopts this labor-saving ruse. Once a fixed deposit has been established, the normal fat reserves are held at a minimum, while every available surplus is locked away in the fixed deposit and is therefore taken out of normal circulation. 3 basic causes of obesity. 1. The inherited factor. Assuming that there is a limit to the diencephalon's fat banking capacity, it follows that there are 3 basic ways in which obesity can become manifest. The first is that the fat banking capacity is abnormally low from birth. Such a congenitally low diencephalic capacity would then represent the inherited factor in obesity. When this abnormal trait is markedly present, obesity will develop at an early age in spite of normal feeding. This could explain why among brothers and sisters eating the same food at the same table some become obese and others do not. 2. Other diencephalic disorders. The second way in which obesity can become established is the lowering of a previously normal fat banking capacity owing to some other diencephalic disorder. It seems to be a general rule that when one of the many diencephalic centers is particularly overtaxed, it tries to increase its capacity at the expense of other centers. In the menopause and after castration, the hormones previously produced in the sex glands no longer circulate in the body. In the presence of normally functioning sex glands, their hormones act as a brake on the secretion of the sex gland-stimulating hormones of the anterior pituitary. When this brake is removed, the anterior pituitary enormously increases its output of these sex gland-stimulating hormones, though they are now no longer effective. In the absence of any response from the non-functioning or missing sex glands, there is nothing to stop the anterior pituitary from producing more and more of these hormones. This situation causes an excessive strain on the diencephalic center, which controls the function of the anterior pituitary. In order to cope with this additional burden, the center appears to draw more and more energy away from other centers, such as those concerned with emotional stability, the blood circulation, hot flushes, and other autonomous nervous regulations, particularly also from the not so vitally important fat bank. The so-called stable type of diabetes involves the diencephalic blood sugar regulating center. The diencephalon tries to meet this abnormal load by switching energy destined for the fat bank over to the sugar regulating center, with the result that the fat banking capacity is reduced to the point at which it is forced to establish a fixed deposit and thus initiate the disorder we call obesity. In this case, one would have to consider the diabetes the primary cause of the obesity, but it is also possible that the process is reversed in the sense that a deficient or overworked fat center draws energy from the sugar center, in which case the obesity would be the cause of that type of diabetes in which the pancreas is not primarily involved. Finally, it is conceivable that in Cushing's syndrome those symptoms which resemble obesity are entirely due to the withdrawal of energy from the diencephalic fat bank in order to make it available to the highly disturbed center which governs the anterior pituitary adrenocortical system. Whether obesity is caused by a marked inherited deficiency of the fat center or by some entirely different diencephalic regulatory disorder, its insurgence obviously has nothing to do with overeating, and in either case obesity is certain to develop regardless of dietary restrictions. In these cases, any enforced food deficit is made up from essential fat reserves and normal structural fat, much to the disadvantage of the patient's general health. 3. The exhaustion of the fat bank. But there is still a third way in which obesity can become established, and that is when a presumably normal fat center is suddenly, with emphasis on suddenly, called upon to deal with an enormous influx of food far in excess of momentary requirements. At first glance it does seem that here we have a straightforward case of overeating being responsible for obesity, but on further analysis it soon becomes clear that the relation of cause and effect is not so simple. In the first place, we are merely assuming that the capacity of the fat center is normal, while it is possible and even probable that the only persons who have some inherited trait in this direction can become obese merely by overeating. Secondly, in many of these cases the amount of food eaten remains the same, and it is only the consumption of fuel which is suddenly decreased, as when an athlete is confined to bed for many weeks with a broken bone, or when a man leading a highly active life is suddenly tied to his desk in an office and to television at home. Similarly, when a person, grown up in a cold climate, is transferred to a tropical country and continues to eat as before, he may develop obesity because in the heat far less fuel is required to maintain the normal body temperature. When a person suffers a long period of privation, be it due to chronic illness, poverty, famine, or the exigencies of war, his diencephalic regulations adjust themselves to some extent to the low food intake. When then suddenly these conditions change and he is free to eat all the food he wants, this is liable to overwhelm his fat-regulating center. During the World War II, about 6,000 grossly underfed Polish refugees who had spent harrowing years in Russia were transferred to a camp in India where they were well housed, given normal British Army rations and some cash to buy a few extras. Within about 3 months, 85% were suffering from obesity. In a person eating coarse and unrefined food, the digestion is slow and only a little nourishment at a time is assimilated from the intestinal tract. When such a person is suddenly able to obtain highly refined foods such as sugar, white flour, butter, and oil, these are so rapidly digested and assimilated that the rush of incoming fuel which occurs at every meal may eventually overpower the diencephalic regulatory mechanisms and thus lead to obesity. This is commonly seen in the poor man who suddenly becomes rich enough to buy the more expensive refined foods, though his total caloric intake remains the same or is even less than before.